Hey everyone, so we got notes. This will be the last notes for the section. And in this section, we're going to solve a right triangle. And we've actually gone over everything, or like all the info we need to solve a right triangle. We've gone over that. This is kind of just wrapping it all up and using it together. So whenever we solve for a right triangle, it's the process of finding the measure of all the side lengths and the measure of the angles. So every right triangle has 3 side lengths. We got to find the measure of the 3 side lengths. And every right triangle has 3 angles. So we got to find the measure of those 3 angles. That's what it means to solve a right triangle. Okay. If you look for finding the side lengths, there's 2 things we can use, and it kind of depends. What we use depends on what information is given to us. Okay, we can either use the Pythagorean theorem. Remember, we went over the Pythagorean theorem before. That was a squared plus b squared equals c squared. It's been a while since we used this, but you should still remember how to use it. And then this is a new one. Well, it's newer than the Pythagorean theorem, but we've been working with this. We can also use our trig functions to find missing side lengths. And just quickly remember, sine of A is opposite of hypotenuse, cosine is adjacent hypotenuse, and tangent is opposite over adjacent. So those are the 2 things we can use for finding side lengths. And then to find an angle measure, let me go down. To find the angle measure, we can use the triangle angle sum postulate. This one is actually, I think it might be from first quarter or the beginning of the second quarter. It's been a while, but just remember the 3 angles in a triangle equal 180. So let's say real quick, if I have a triangle like this, and then this side is 50. This side is, I don't know, 60. That's a 110. So this one would have to be 70, because together they add up to 180. Okay. So that's the triangle angle sum. Remember that. We can use that to find missing angle measures. Or this one is something we just went over, inverse trig ratios. We can use the inverse of sine, inverse of cosine, or inverse of tangent to find missing angles. And we've been doing this for the last 2 days, 2 class meetings. Okay. So copy that. I'm going to continue. And then just kind of remember, I've brought this up in different lessons and notes. Capital letters represent angles, and then the lowercase letters represent sides. And usually, this may not always be the case, but usually, in general, especially the higher math up you go, the lowercase letter is across the capital letter. Like, see how here it's little a? Across from little a is capital A. The same thing for C. I don't want to fill this up with a bunch of lines, but across from C, capital C is lowercase c, and then across from B is lowercase b. Okay, so let's say we had a triangle like this, and this angle was A, this angle down here was B, and this one is C. I know where little a goes, because if this angle is A, if I go across angle A, the side I run into is side A. Same thing here, if I go across angle C, the side I run into is little c, and if I go across angle B, the side I run into is going to be little b. And then if the letters A, B, and C are being used, C tends to be the hypotenuse. And again, that goes back to the Pythagorean theorem, a squared plus b squared equals c squared. So pause this, copy it, and then we'll get. So here's our first example. Solve the right triangles, and there's 2 down here. I have another one over here. So again, to solve the right triangle, we have to find the measure of the three angles and then the side lengths for the three sides. Okay? And then you have to be able to look at the diagram and then figure out what goes where. Because some of this information is in the diagram. Okay? Like C. This is angle C. You guys should know because this has the little square here. We know angle C is 90 degrees. So wherever the little square is, that's 90 degrees. Okay? And then this top angle, angle A, I know angle A is 57 degrees. Now, I can figure out the measure of angle B by using the triangle angle sum conjecture. Because I know these three angles. I know if I add up 57 plus whatever this is plus 90, if I take those three angles and add them up, it has to equal 180, right? So if I want to figure out the one that's missing, I can just do, and some of you guys are going to remember this, I can take the 180 and subtract out the two that I know. So 180 minus 90 minus 57, that equals 33. So I know angle B is 33 degrees. This bottom one, you don't need to put it into the diagram, but I'm going to put it in the diagram. That way I know what I found. And then from the diagram, we also know that this one down here, because it's across angle A, I know 15 is little a. I know 15 is little a. Okay, you should know that. Again, capital A and little a are across from each other. And now we need to find actually little b and little c. Now to find little b and little c, we can look at either one of these angles. Let's say I'm going to identify one of these angles, and then we're going to figure out the different side lengths, and we're going to use our trig ratios. Since 57 was given, let's go ahead and just use this angle 57, which is angle A, right? Since this is angle A, this is the one I'm looking at. I know C is the hypotenuse. B's the adjacent leg because it's close to angle A, and then 15 is the opposite leg because it's across. Okay, so then I can write this ratio to find B. I have this one, opposite and adjacent. I can use that ratio, and that's the tangent ratio. Tangent of angle A, which I know is 57, is equal to the length of the opposite side over the length of the adjacent side. And then I can solve this, and that'll give me my measure for B. Now remember, when we solve this, put a 1 under there, cross multiply so you don't grab the variable, and divide by what's left over. So if I type that into the calculator, it'll look like this. 1 times 15 divided by tangent of 57. What is that, 9.7? So I know B equals 9.7. Now if I wanted, I could use the Pythagorean theorem now. A squared plus B squared equals C squared, but I'm not going to. I'm going to use opposite and hypotenuse, which is the sine ratio, to figure out C. So we know, let me just draw a little squiggly line in here. We know sine of 57 degrees is equal to the length of the opposite leg divided by the length of the hypotenuse. And those are the trig ratios. We wrote them down on the other side. You should remember them. Again, put a 1 under it, cross multiply so you don't grab the variable, and then divide by what's left over. So that one looks like this. 1 times 15 divided by sine of 57 degrees. Push enter, and that is 17.9. Okay, 17.9. Maybe in some of the class examples I'll use the Pythagorean theorem, because we can use the Pythagorean theorem to solve these. So copy that, or pause it and then finish copying it. I'm going to do the next. So if you look at the next example, again, some of this information, this missing information we can find from the diagram. C, again, C is the 90-degree angle. So I'm going to go ahead and put 90 here. I don't know anything about A. I don't know anything about B, so I'm not going to put anything else for the angles. But I do know that's little c. And then this one down here, the 14 is across capital B. So I know this one is little b. And then for this one, because I do have nice whole numbers, I will use the Pythagorean theorem to find A. So watch, if I use the Pythagorean theorem, remember the Pythagorean theorem is a squared plus b squared equals c squared. Okay, a squared I don't know that one, so I'm going to leave it there. B squared is 14, and then c squared is 16. So then if I figure out 14 squared, that's a squared plus 196, and I believe that's 256. Yeah, 256. Subtract 196. I'm just gonna subtract it on the calculator. You get 60, and then remember when we were here, the last thing we do, I'm gonna put it in a different color, that way it stands out. Let's take the square root of that, because squares and square roots cancel. You're left with a, and then the square root of 60 is 7.7. It's not a nice number like I wanted, but still, it works. So now we have the 3 side measures. Now we need to figure out either A or B. Since I haven't written too much over here on A, let's go ahead and find angle A first. So I'm gonna circle that angle. That means we're kind of going off of this. So now we can name the sides. I know 16 is the hypotenuse because it's across C, and then I know 14 is the adjacent side because it's right next to A. Okay, so that means adjacent hypotenuse, that's the cosine ratio. So cosine of angle A is equal to the adjacent side over the hypotenuse. Now remember, if I'm going to use a different color. I want to know what A equals. Well, if I want to know what A equals, that means I need to get rid of cosine. If I want to get rid of cosine, I need to use cosine inverse. So remember in the notes I said we use the inverse to figure out the angle measure. And then we can just type that in the calculator. Second cosine 14 divided by 16. Make sure you round to the tens place. Well, that looks like it's 30. Right, so I'm just going to put 30.0 because actually not 30 but 29. How about 29.0? So that's angle A. And the good thing about this one is we don't have to do it again to figure out B. I can just subtract these two from 180 like I did for example A to find out B. So I take 180 minus 90 and minus 29, and that equals 61. So I know this is 61 degrees because, again, those 3 angles added up have to equal 180. And that's it. Let's do some examples in class.